For work done to be maximum, the angle between the force and displacement should be. So the answer is 0 degree. If you see the expression for work done is equal to F multiplied by D displacement multiplied by cos theta. So if we are talking about the cos theta, it will give us the maximum value at 0 degree. Cos 0 is 1. So for maximum work, cos theta should be maximum. So that is why the angle should be 0 degree for the maximum work. Let's go to the next question. When a ball of mass m is thrown upwards to a height h, the work done by the force of gravity is. They're asking work done by the gravity, not by us. So now if you see this diagram, here as a point I have represented the ball. So it has a mass m, say. So its weight will be acting downwards. So this is the gravitational force, downwards, vertically downwards. And remember, we are throwing it upwards to this side. So the angle between displacement, which is vertically upwards, and force of gravity is 180 degree. So what will be the work done? We can use this formula F dot D or Ft cos theta. Then force will be mg into h, because h is the displacement, into cos 180 degree. So 180 degree cos is -1. That's why we are getting minus mgh. Okay, now if somebody asks what is the work done by us, if we are throwing it or pushing it upwards like this against the gravity and keep the ball here. So how much work done is done by us? By us, it is a positive work. So then the answer will be mgh. So be careful about uh, which force they are asking to calculate work done for. A coolie takes 1 minute to lift a load to the roof of a bus, whereas coolie B takes 2 minutes to lift the same load to the roof of the same bus. The work done by B is. See, work done doesn't have to take account of how much time it has been taken. In work done formula, if you'll see, it is force and displacement. And both A and B are lifting the same load to the same roof of the same bus. So the height is also same. The force is also same. If force and displacements are same, we will say work done is also same. So the work done by B is equal to work done by A. The energy of electron is 2.5 electron volt. When expressed in joules, it is, so it is just a unit conversion question. So 1 electron volt is 1.6 into 10 to the power minus 19 joules. So 2.5 will be just multiplication of it. So we just need to calculate what will be 25 into 16 and use decimals. You will get 4 into 10 to the power minus 19 joules, and B will be the answer. Okay, let's see the question number 6. A block of mass 20 kg is pulled up by a slope as shown in figure. So this figure we need to focus on. With a constant speed, it means there is no acceleration, by applying a force of 200 Newton parallel to the slope. So if this is the slope, we are applying force parallel to the slope. Remember that. From the initial position A to the final position B. So this is A, this is B. Work done in moving the block from A to B is. So the force is this way, parallel to the slope, and displacement is also this way. So they have the same direction. So the theta, which is the angle between displacement and force, is 0 degree. So if we use this formula, we'll get the answer as 600 joules. So why this question? Because we can be confused because we are pushing it on the slope. So we might think, maybe some answer will be different. We have to focus on the work done formula. And if that force is given, we just need an angle between this force and displacement. And in this case, it was cos 0 degree. So that's why we need to focus on what is needed to answer the question other than, how the question is framed. This was just done to confuse us. Let's see question number 7. A graph is given, force displacement graph is there, and they're asking what is the total work done by force. If we displace it from 0 to 6, so this is 0, 0, 6. Below at x-axis, there is a displacement. On the y-axis, it is force. Now, how we can calculate? If a force displacement graph is given, if we are able to calculate the area, that area gives us the work done. And how come, just imagine, if we are calculating this, say this rectangle's area, are not we multiplying force into displacement, this much displacement, this much force, right? So we are actually using the formula of work done again, but in a graphical way. Anyway, so we can calculate the areas here. What I do is I separated in 3 areas, 1, 2, 3. One is this triangle, other is this rectangle, and other is this triangle. So we calculate this. I've done like half into base into height. Height is 10. Then rectangles area will be, see, this 2 into 10, and then again the rectangle half into 2 into 10. So you will get the 40 joule as answer. You can of course apply the area for trapezium for these kind of formulas, but what I generally do is I divided it in triangles and rectangles and get the total of it. Now next question is assertion based question. When the displacement is normal to the direction of force, when the displacement is normal, normal is the fancy word for saying 90 degree. So displacement is normal to the direction of force, work done is 0. Yes, because cos 90 is 0. Second, work done depends on the angle between force and displacement. Yes, so this actually is reasoning about why normally we are saying if they are, the work done is 0. So it is explaining that. So the A option will be correct. Both A and R are true, and R is the correct explanation of A. So we will go with the option A. Let's see the next question. Assertion: work done by frictional force is negative. Reason: this is because frictional force acts along the direction of the motion. Along, they want to say in the same direction here. So if we take the main meaning of this word along as same direction of motion, so this reason is wrong, right? So work done by frictional force is negative. So first understand whether this is correct or not. Imagine you are pushing a box, okay? Pushing a box. Take this cursor for example. So if this is a box and it's moving like this, the motion direction is towards the right, but the friction will be on the opposite side. The friction will act opposite to it. So the displacement is happening to the right and the friction force will be acting to the left. So they will have 180 degree between them, and cos 180 is -1. In the work done formula, it will make it negative. So that is why work done by frictional force is negative. But this is reasoning is wrong. because frictional force does not act along the direction of motion. If that happens, it means if you're pushing a box, friction will help you because it will be in the same direction. It is a force, friction is a force, so it will help you in pushing the box. No, it opposes us in moving. So it is in acting in the opposite direction of motion. Okay, that's it for 2A exercise. Thank you.